Alright, so here's video 2. In this video I want to talk about some tips and wisdom, things that will absolutely help you all semester. And you might actually want to take some notes for this. I have 10 tips that I'd like to convey. And after this video, I'll do a third on mathematical preliminaries and a fourth, which will basically be chapter 1. There isn't a lot to chapter 1, so that's what will come next. But let's talk about tips and wisdom. Again, here are my 10 tips. First off, I mentioned earlier that this is some good stuff, but it's not easy. It's cool, but it's not easy. Really interesting. Some of you haven't taken a physics class before, and to those who are in that category, you'll be faced with more rigor, most likely, than you've ever had in another class before. It'll build on all of your mathematical background and all of your science background, or a lot of it, particularly some chemistry. So what I'd like for those of you in that group to keep in mind is really take it seriously and go to town on the rigor. And if after 2 or 3 months you say, this isn't really that bad, well, great. But I don't want you to be in the reverse situation where you just weren't giving it enough energy and you fall behind. This is the real surprise. And it took me 2 or 3 semesters to figure this out. Those of you who have taken physics before, you're actually at a high risk too. I had one student, one semester, he was brilliant. You could just tell he was right on top of things. He was engaged. He asked really good questions. He had taken physics in high school, I think maybe even AP physics, and he didn't do any of the homeworks. Doing the homework is imperative. And when we got to test 1, he got I think a 41. It was awful. And he came up to me after class, and his mouth was open. He's like, I don't understand. I was like, he didn't do the homework. So for those of you who have taken this before, don't go with the flow. Take it seriously, because I'm going to be teaching things a little bit differently, perhaps, than the way you've heard them before. Our textbook may present things differently. In fact, we're going to be covering material that you haven't covered, even if you've taken AP Physics, most likely. So be careful. Don't fall behind, and stay on top of everything. Again, if I'm being too conservative here, best to err on that side initially. Tip 2, and this is sort of a recap of something I said last video, the course is inherently cumulative. So falling behind is really bad. Don't fall behind, because there's no way that we're going to reach a plateau of something ultra brand new that doesn't build on what we've done before. So keep up. Tip 3, you can't just watch. And I like to give the example here of playing guitar. Maybe some of you play guitar, or piano, or do you have a 5-speed? If I do my job really well, and I'm in front of class, and let's just say, for example, I describe to you how to play an E chord on a guitar. Again, I could be really clear, and you press, this string on this fret, and it would make perfect sense to you, and you would think, I got that, if I do a really good job. Taken further, I could bring a guitar. This is the first time I've actually had props that I could use, but I'm not going to do it. I could bring a guitar into class, and I could play an E chord. And you would look at me, and you would say, oh, cool, I got it, I could do that. The thing is, you can't just watch. If you don't go home and practice over and over and over again, you're not going to really know how to play that E chord, or drive that 5-speed, or even ride that bike, right? Riding a bike is something that we all see all the time. And remember the first time you got on a bike, you probably fell off. You can't just watch, you've got to do the homeworks yourself, privately and in groups. Tip 4, do every single homework problem that I assign to you. Now, it's not small potatoes. You should probably budget about 15 to 20 minutes per homework problem. Probably at least 2 to 3 hours of homework a week. This is the only way that this stuff will really burn in. Again, when you were learning to play guitar, when you were learning to play piano, driving a 5-speed. How often did it take you to, how many times did the car stall when you were trying to, like, shift? I don't know about you, but it didn't go well for me. Number 5, be as neat and clear as possible. Those of you who have an affinity to being meticulous will actually have an advantage, because some of the problems, especially as the semester goes on, get more and more involved, and it's increasingly probable to make an error, especially if you're not neat. So try to be as neat and clear as possible, and for every problem, draw a picture. Drawing a picture is imperative. You're going to see every problem that I do in class, I'm going to start with a picture. Now, my pictures are terrible. I have no artistic capabilities whatsoever, but that doesn't matter. It's not how beautiful the horse looks or the shark. It's having a picture to get you in the frame of mind for what we need to solve. And you're going to see, again, as the problems get increasingly complicated, we're going to be adding more detail to them, angles and force designations and coordinate axes. All the pictures are going to get busier and busier is the bottom line. So be as neat and clear as possible, and always draw a picture when you solve a problem. Tip 6, if you start getting sloppy when you're starting to do a homework problem, start over. Now, we're all very attuned to the environment. We're all becoming scientists and engineers because we want to make the world a better place. I'm giving you a little bit of permission in this class to waste just a little bit of paper, because the reality is, if you start getting sloppy, you're going to more likely than not make a mistake, and then you're going to have to do it again anyway. And with each iteration, you're going to get more and more frustrated. So if you start to get sloppy, start over. Number 7, get extra help when you need it. I didn't say if you need it. I said when you need it. I mentioned in the last video, I'll be there a little bit before class. I'll be there a little bit after class. You can email me all the time with details as to where you're stuck, what you think, how far you've gotten. Across the hall, we've got Michelle in the lab with office hours posted, where she basically tutors. So, and she's very familiar with all these problems. So you can go to her, you should schedule some time with her. I wouldn't just pop in. You might want to just get a half-an-hour block so that she's available for you. So when you need extra help, get it. And of course, you can do that with your classmates as well. Number 8, interpretation is a huge part of physics. I always hated the phrase plug and chug. You go to a math class and you've got to solve a problem, and maybe you're doing something like integration by parts, those of you who are taking the calculus. And so you're going to go through 10 problems and you have to use this integration by parts. It's hard, but it's chug and plug. The problems in physics are all inherently word problems. All of the problems that we solve as engineers and scientists in real life start with words. We need to figure out how to now I can't think of one. We need to figure out how to, what is the incline that we need to bank this curve at so that people leaving a highway are least likely to skid. That problem started with words. So you need to step back and think about the words, morph it into a problem that you can solve with physics. That will inevitably become a math problem that you need to solve. And then you need to look at the answer. So at 2 times, you're not just plugging and chugging here. When you're thinking about those words, that problem, you got to really sort of right brain it a little bit, right? The left brain is the logical plug and chug kind of brain. The right brain is the creative, what does this mean, philosophical type of brain. So you got to use both. So initially, you got to figure out what that problem really means. Then you morph it into something that you can do physics on and do math on. When you get an answer, does this make sense? So you have to invoke both parts of your brain at all times. And this is why the homework is so important. You've got to go through those. You will get them wrong a lot. And then when you finally start getting them right, great. And then we'll move on to the next chapter and it'll start again. Help each other. Tip 9. I like to do introductions. We're a particularly big class, so there won't be time for that. Plus, we're still playing catch up a little bit next week. But very often I come into the classroom and there's a few students at the whiteboard solving problems together, or across the hall there's another nice classroom behind the glass They're in there solving problems together. I had one group actually that was meeting at Barnes & Noble on Sunday, having coffee and solving physics problems. So get to know each other. From lab, you'll be interacting a lot and help each other. And the last tip, don't be late to lecture. And that's not me being a bureaucrat. What'll happen is in the first 5 or 10 minutes, I'll spin things up, and then we'll be knocking through it. If you miss the tee-up, the why we're doing what we're doing, what we're about to do, it can be very hard to catch up. So try your best not to be late to lecture. Okay, so that ends video 2. And like I said, the next video will be mathematical preliminaries. We're still not in the actual course material yet.